One thing you may be asked to do with lines is graph them. So that means we're going to take the rule of the line or the equation and put it onto a graph. We're going to draw the actual line. And there are two ways that we might do this. One way is using a table of values, and the other way is using rate of change or slope and initial value or y-intercept. So let's look at both ways. Let's look at using a table of values first. So when we're creating a table of values, here's what we're doing. We are going to make a table, and it'll be a little sketch of a table. And what we'll put in this table are some x values and their corresponding y values. We get to pick any values of x that we want. And let's pick maybe 4. That'll give us a really nice line. And it doesn't matter which 4 you pick. So I'm going to kind of pick maybe 0, and let's pick 2, and maybe 5, and 7, and 10. It's more points than I need. Maybe let's take 1 away. Let's take away 7. We don't need to do quite that many. Okay, so we have our 4 x values, 0, 2, 7, and 10. And we need to find the y values that go with them, right? Remember, points, each point on this line is going to have an ordered pair, an x and a y, right? So we need to know the x, so from the origin, how many over we go, and the y, how many up we go. So to do this, we're going to solve for y given x, right? So we have the equation y equals 2x plus 3. So for our first point, let's only worry about this point that's x is 0. Instead of writing x here, we replace it with 0. So y equals 2 times 0 plus 3. Now, y is already by itself, so we don't have to do any algebra. We just have to put all of these numbers together. And when we put all of these numbers together, we have to use BEDMAS. Remember BEDMAS? Let's write it. BEDMAS. This means we do our brackets first, and then our exponents. Division and multiplication come together as a pair, and addition and subtraction come together as a pair. So that means we have to do any multiplication and division before we do any addition and subtraction. Well, we have some multiplication, so we have to do that. 2 times 0 is 0. So we have y equals 0, and then we add our 3. And now we can do our addition because there's no more multiplication. So y equals 3. So this 0, when x is 0, y is 3, which means the line has to go through the point 0, so we don't move any side to side, and 3, 1, 2, 3. We have to go through this point here. We're going to do the same thing for the rest of these lines. For the rest of these points. We're going to keep solving for y given x. So let's do the next one here. We still start with the same equation, y equals 2x plus 3, but now this time x is 2, right? We don't care about the x is 0 anymore. We have that pair. Now we care about x is 2. So y equals 2. Instead of writing x, we'll replace it with this 2 over here. We do our multiplication first. 2 times 2 is 4. And then we have our 3. So y equals 4 plus 3 is 7. So we know that the line has to go through the point 2, 7. So let's put a dot there. So we start at the origin, we go to x is 2, and then we go up to 7. Let's keep going. We'll erase these 2 up here, so we'll have room to do our last 2. So we start by writing our equation just like we always do, y equals 2x plus 3. And now this time, x is 7, right? Because that 7 was the next number we picked. Y equals 2 times 7 plus 3. So y equals multiplication first. 2 times 7 is 14 plus 3. So y is 17. So 7, 17. So if we went to 5, 6, 7, we would have to go all the way up to 17, and that's off our graph, right? So we can either estimate it or we don't have to put it on. And that's going to be true for x is 10 as well, but let's solve it. Y equals 2, x is 10, so 2 times 10 plus 3. 2 times 10 is 20, and then 20 plus 3 is 23. So we know that the line goes through the point 10, 23. So again, we can estimate it, or as long as we have 2 points on our graph, we can make the line. So then you would take a ruler and connect these 2 points. Let's see if I can do a nice job here. It has to go through. We can adjust this a little bit if we want to. There we go. So you would take a ruler and just make sure that your line goes through those 2 points. And we always put little arrows at the end of the lines that we draw. And what that means is that these lines keep going on, right? It means that if our graph was big enough to go out to 717, this line would go through the point 717, way up here, but our graph just isn't big enough. So these arrows just tell us that the line keeps going on and on. So that's using a table of values. We pick some x's, we solve for the y's, we put those points on the graph, and we connect the dots. There's another way of graphing a function as well, and let's take a look at that. The other way is to use rate of change and initial value. So remember, if we have the line y equals ax plus b, we have y equals ax plus b. Remember, a is our rate of change, right? This is our a, and b is our initial value. So a, rate of change, we'll say ROC. B is our initial value. Remember, our initial value is where the line crosses our y-axis. So if we take an equation, we can determine our rate of change on our initial value, and we can plot those points. So let's take a look at what that actually looks like. So here's an equation of a line. Y equals 2/3 x minus 5. So a, our rate of change, is the number that's right in front of our x. It's 2/3. And b, our initial value, is -5. So what we do, now that we have our a and our b, the first thing we do is we put our dot at our initial value. And our initial value is always 0, right? We aren't going side to side at all for our x's. And then our b value, -5. So x don't go anywhere, b, -5. And we're going to put a dot there. And it's always on our y-axis. Our b is always on this y-axis somewhere. Then from this point, we start here. From this point, we use our slope, or our rate of change, to find the next point. So here's how we do it. Our rate of change is rise over run. Rise, how many up or down we go. Run, how many over. So if our slope is positive, see how this 2 is positive and this 3 is positive? If the slope is positive, this means we're rising, we're going up 2 and over to the right 3. So from this point right here, the first dot that you put, you go up 2, so 1, 2, and over 3, 1, 2, 3. Here's our second dot. And we could do that again. From this point, we could go up 2 and over 3. And we could do it again, up 2 and over 3. We're building a staircase. And then up 2, over 1, 2, 3. We're at the edge of the graph. And now that we have a whole series of dots, we're going to draw a line that connects all of them. So there's a line not quite on, so we'll move it around just a little bit. You would use a ruler to connect those dots, and so you could get it right the first time. And then we always put arrows on the end of the lines. It'd be nice if we did in the same color as the line. There we go. Now, if our rate of change was negative, so if this was negative 2/3, from this dot we would go down 2 and over 3. So if rate of change is positive, we go up. If rate of change is negative, we go down, and we always go to the right. Let's look at one more example. So here's one more line. We have the line 4y minus 2x equals 8. Well, this isn't in the form that we know, right? Y equals ax plus b. So we have to do a little bit of algebra to make that happen. We want y all by itself, so we have to do some algebra to get rid of other things. Remember, we get rid of our addition or subtraction first. So we need to get rid of this negative 2x, so we'll add 2x to both sides. We're left with 4y equals, these go away. We have x's and not x's, so we can't put them together, so we'll just write 2x plus 8. And then we'll divide everything by 4, right? If we divide this side by 4, remember that means we have to divide all of our numbers on the other side by 4. Divided by 4, divided by 4. So these 4's go away. We're left with y equals 2 divided by 4. Remember, it's important to keep this as a fraction. And then we have our x's plus 8 divided by 4 is 2. We don't have to keep this as a fraction. The reason why it's really important to keep this as a fraction is if it's not a fraction, it's much tougher to graph our line. So let's look at what this graph looks like. Our A, our rate of change, is 2 over 4, and our B, our initial value, is 2. So, step 1, determine the rate of change in initial value. We've done that. Step 2, plot the initial value at 0b. So we want to put a point at 0, 2. So there's 0, here's 2. So that's our next step. From 0, 2, so from that point that we just did, we're using rate of change to plot another point. Rise, run. This is positive, so we're going up, and we always run right. So from this point, from our 0, 2, from the point from our first dot, we go up 2 and over 4. From that dot, we can go up 2 and over 4. And then up 2, and that's right at the edge of our graph. And then we'll connect those dots. There we go. That wasn't bad for the first attempt. Let's put some arrows at the end of this line, just to remind us that this line goes on and on forever. And there's the graph of the line. So you can either use a table of values like we did in the first example, or you can use initial value and slope. Either way, you'll plot some points, and then you'll use a ruler to connect the dots, and you have your graph.